Today, we will see how do we solve exponential expressions using the same base technique. Now, the main idea here is that whenever we're talking about equations and you see that your exponent has a variable, the first thing that you want to see is try to see if you can write both sides of the equation using the same base. There are many ways for you to solve equations where your variable is your exponent, but first, we're going to start with the basics and we're going to see if you're able to write each side of the equation using the same base, then we will do that because you will see in the next example why that is helpful. So the main idea here is that we're going to try to write both sides of the equation using the same base. So let's get some examples here. Now, let's try to solve the following equations here. So here in example 1, we want to solve for a. We want to give a numerical value for a. But notice that a isn't your exponent. Now, when you have an equation and you have the same base, here the base is 3 because it's 3 to the 2a, and here's 3 to the negative 1a. The moment that you have the same base on both sides of the equation, they will cancel out, and now you can set the exponents equal to each other. So now we have 2a equals negative a. And now we want to solve for a here. Well, let's add a. So that means that 3a equal to 0 divided by 3. So here it says that a is equal to 0 because 0 divided by 3 is just 0. So here's the idea. The moment that they have the same base, we want to write them using the same base because the moment that they have the same base, they will cancel each other and you will put the exponents equal to each other. And that is a technique that we will be using to solve for expressions or equations where we want to solve for the variable, and the variable it's in your exponent. So let's see here. I notice that my exponent has the variable, which is x. I notice that there's an equal sign, and they already have the same base. So what can we do? Well, the moment they have the same base on both sides, the bases will cancel each other. So now we just have 2x plus 2 equals 3x. And now it just becomes an Algebra 1 problem. Let's solve for x here. So minus 2x here. So now it says that 3 minus 2x, that's just 1x. So that this is just saying that x is equal to 2. Now, there's times where you want to just double check if your answer is true. We would not do that in this video, but just make sure that when you have an answer, you got to check your work. How do we check it? We plug in this x to 2 to both variables and see if the left equals to the right. Now, notice here in example 3, we still want to solve for that exponent. We want to solve for k here. K is my exponent, but notice that they don't have the same base, so you cannot just cancel that out right away because we just do that whenever they have the same base. They don't have the same base, we cannot do that. So what can we do? Well, first, try to see if you can rewrite 27 using base 3. Well, I know that 27 is equal to 3 to the third. So that means that 27, I can rewrite it as base 3. 27 is 3 to the third. So let's rewrite this 27 as base 3. So instead of writing 27, I can write 3 to the third. So now this becomes 3 to the third. 2k equals 3 to the fifth. Notice that all I did, I just rewrote that 27 into a base 3. Because I know that the moment they have the same base, I can cancel them out. So now we have the rule of exponents is if you have an exponent, you just multiply. So this becomes 3. 3 times 2k, that's 6k, equals 3 to the fifth. So notice that all we did, we just rewrite it using base 3, because now that they have the same base, now they can cancel each other. So now this just becomes 6k equals 5. Want to solve for k, you got to divide by 6. So at the end of the day, k is equals to 5 over 6. They need to have the same base if you want them to cancel it out. So if they don't have the same base, see if you can rewrite either side of them to have the same base. We notice that 27 I can write as the base of the other, which is 3. 27 is 3 to the third. Then I multiply the exponents. Now they have the same base. They can cancel each other. And then you just solve. So now let's look at another example here. Look at example 4. I notice that my exponent has the variable that I'm looking for. Well, let's check if I can rewrite them having the same base. Well, what do you notice here? Notice that 81, I can rewrite that as 3 to the fourth. So let's go back to our problem and try to write them having the same base. So the left remains 3 to the 3x minus 2. And 81, I can just rewrite that as 3 to the fourth. Again, all I'm doing is just try to rewrite them to have the same base, because what happens when they have the same base? The moment that they have the same base, we can just cancel the bases here. Now that they have the same base, they can cancel each other. So now we're just going to set the exponents equal to each other. So now this becomes 3x minus 2 equals to 4. Now we solve for x. You got to add 2. So now this becomes 3x equals 6. Subtract 3. So x is just 2. So notice that all we're doing here is we're going to try and rewrite every single base, every single side, or just the left and the right side, using the same base. Now let's look at example 5, which it looks a little more difficult, but they still follow the same rule, because you gotta have an idea as to what is it that you're looking for. We're looking for x, which is an exponent. So the only technique that we have seen so far is to write them having the same base. But can I write 27 as base 9? No. Or can I write 9 as base 27? No. But is there a base that both of them share in common? Well, let's see. 9, I can rewrite that as 3 to the second. 27, I can rewrite that as 3 to the third. Because 3 to the second, that's 9. 3 to the third, that's 27. So notice that both sides, I can rewrite them having base 3. So let's do that. Instead of writing 9, I can rewrite 3 to the second. So now this becomes 3 to the second. Exponent 2x minus 5. And on the right side, instead of 27, I can just write 3 to the third. Now we can distribute this exponent. So now this on the left side, we have 3. 2 times 2x, that becomes 4x. 2 times negative 5, so that's negative 10, equals 3 to the third. Notice that they have the same base now. So what can we do? We can just cancel them out. And now we're just going to set the exponents equal to each other. So now we're going to have 4x minus 10 equals to 3. And now we just solve. Plus 10. So now we're going to have 4x equals 13 divided by 4. Let's put a final answer here. So it says that x is equal to 13 over 4. Notice that all we're doing is we're using the same technique. Try to write each side using the same base. So let's look at our final example here, example 6. In example 6, notice that what we want is on our exponent. So let's see if we can rewrite either 25 and 125 using the same base. Well, I know that 25, I can write that as 5 to the second. And I know that 125, I can rewrite that as 5 to the third. So let's come back to our original examples and try to rewrite both sides using the same base, which we found it to be 5. So 25 I can write as 5 to the second. So the left side becomes 5 to the second, x plus 1. And now the right side becomes 5 to the third, exponent 5. Because 125, that's equals to 5 to the third. So that 5 still remains outside. 25 is 5 to the second. We got an exponent of x plus 1, so we got to put us in a big parenthesis outside. So this is what we have now. So let's just simplify. Let's multiply the exponents here. So now this becomes 5. 2 times x, that's 2x. 2 times 1, that's just 2. Plus 5. 3 times 5, that's just 15. So this is what we have now. They have the same base, so we can cancel them out. So now we're just going to set the exponents equal to each other. So now we have 2x plus 2 equals 15. And now we just solve in minus 2, cancel each other. So we have 2x equals to 13 divided by 2. And now this says that x is equal to 13 over 2. So the main idea here is to make sure and try to see if you can write both sides using the same base, because the moment that they have the same base, you can go ahead and cancel each other out. Here's your entrance ticket. Try to solve the following.